Okay, in this video, we are going to talk about a complement of a set. So we're going to look at section 2C and just some terminology that we're going to have to know. So a universal set, the symbol of that is going to be U, and it is all the elements within the set. So absolutely everything that would fall under the set that is being talked about. The complement of a set is going to be denoted by a prime or the prime of any number essentially. So if I have set A, then the complement would be A prime. If my set was S, then the complement would be S prime, which means it's everything that's not S in that particular situation. So there's three different things that we can observe. So if you recall, this right here is meaning intersection. So A and A prime, it is going to be an empty set. There is no intersection because if you are A, the complement means it's everything that's not A. So there is no intersection there. Now the union of A and A prime is going to be all of that universal set, everything that is being talked about. And then the other thing that we can observe is that the number that is in A plus the number that is in A prime is going to be the total number of values or of elements, I should say, in your universal set. And again, that's provided that it is a finite set. So let's just do some examples. So, number one, it's asking us to find C prime given that U is all positive integers and C is all even integers. So if we're talking our positive integers, we're talking 1, 2, 3, 4, 5, 6, 7, 8. It's your counting numbers. So if C is all the even ones, then the opposite of that, C prime, is going to be all the odd integers. That would be the complement. So then our next one, it says C is, and this is set builder notation. There's missing a line there. X such that X is greater than or equal to 3, and X is an element of an integer. And it's telling us the universal set is all integers, which means that C prime is going to be the opposite of that. So X is going to be or X such that the opposite of greater than or equal to 3 is going to be everything that is less than 3. Granted, X is still going to be an integer, but that would be the opposite of that. So C prime is going to be everything that's less than. Okay, so suppose that the universal set, it's missing all of our bars here, is X such that your X falls between -5 and 5. A is between 1 and 4, and the B is between -3 and 2. So it says list the elements of each set. So A is going to have the numbers 1, 2, 3, and 4. B is going to have the numbers -3, -2, -1, and 0. But notice it is not equal to, so we're not including 2. And because it's all integers, we're not going to have any decimals. So those are your B's. So then A prime is going to be anything that is not A. So in the universal set, we're going between -5 and 5. So A prime is going to be -5, -4, -3, -2, -1, 0, and 5, because those are all the numbers that are not A. B prime, on the other hand, is going to be all the numbers that are not B. So -5, -4, 1, 2. Oh, I'm forgetting 1 here. That's not there. Sorry about that. That should have a 1 there. So 2, 3, and 4, and 5. That's going to be your B prime. So A intersect B, for example, E. What does A and B have in common? They have 1 in common. So A intersect B is going to be 1. A union B